Hello, this lesson is about number systems. We're going to start with counting number, and we call them natural number. Natural number is a category, and we call them natural numbers or counting numbers. So what are they? They are 1, 2, 3, etc., etc. Okay, so these numbers are called natural numbers. And after natural number, we have introduced 0. Okay, 0 is a very, very interesting number, and it's a very, very important number. Because after the introduction of 0, we will have sign numbers, negative numbers, positive numbers, right? So in addition to natural numbers, we have 0, we added 0, and then we're going to call them whole numbers. So what are whole numbers? Whole numbers are 0, okay, and natural numbers. Okay, that is, natural numbers are, whole numbers are 0, 1, 2, 3, and so on and so on and so forth. Okay, so that's the category of whole numbers. After whole number, okay, we have an even larger category. The larger category will be called integers. Okay, integer, what are integers? Well, we have introduced 0, right? So if you look at the number line, if we look at the number line, we have introduced 0, and then we're going to introduce sign numbers. So what are the sign numbers? Which is, what are the integers, right? Which is going to be lots of negative numbers, right? And we're going to have something like -3, -2, -1, 0, and all the natural numbers, 1, 2, 3, etc., etc. So you see, I'm writing these numbers down as if they're on the number line. Okay, so if we think of that we have a number line here. Okay, we have a number line here. Maybe I should change it, change to a different color. Let's use a different color, so that way we can use red for something more important. Okay, so this is the number line. And suppose I have a direction. This points to the positive direction. You do not need another arrow on the other side. Okay, I know some people drawing that, but it's not really necessary. So now we have a place. We have a place for each of these numbers, And suppose that I'm going to put 0 right here. 0 as a very important number, it's a point of reference. So 0 is right here. And -1, -2, -3, and so on and so forth, it goes into the direction to -infinity. Okay, so let me put another number as an example. Say this is a -3. Right, so all the negative numbers on this direction and all the positive numbers on the other direction. Say I'm going to arbitrarily just put, say, just +5. Right, you can see, we can see the number line, and the numbers are in different positions. But there are all these gaps, right? So what after integer? Do we have a larger category of numbers after integer? The answer is yes. And that category is called rational number. Some of you may not have heard of natural number, but natural number are really what? Are really just fractions, okay? So let me write it down. Rational numbers. The composition of rational numbers, actually there's a formula. There's a formula. Okay, so what is rational numbers? Let me write it down. It's just fractions. They're just fractions. Okay, how are these numbers composed? And luckily, we actually have a formula for it. And what is this formula? Just we take every possible integer. Okay, any possible integer. I pick up an integer and put it on the numerator. Okay, so this numerator can be any one of the integer. Denominator, I'm going to put another integer, but this denominator cannot have 0 as a denominator, as we all know that. If we arbitrarily choose, okay, any integer as a numerator, a non-zero integer as a denominator, and we got a fraction, we got a rational number. As we all understand, sometimes we get a repeating decimal, sometimes we don't get a repeating, we get a terminating decimal. So it doesn't matter. So in any form of P over Q, and where P and Q are integers. Okay, so P and Q are integers. You can see how each category is built and it becomes larger and larger. Okay, so these are rational numbers or fractions. Okay, but we use rational numbers. Why? Because next we're going to talk about a category called irrational number. Irrational numbers. What are irrational numbers? Irrational numbers is any number that's not rational. Okay, not rational. Okay, so outside the rational numbers, we call them irrational numbers. Do we have those? Yes, look at them. Okay, for example, pi is an irrational number. Okay, pi is an irrational number because it's neither repeating nor terminating. Okay, so neither repeating nor terminating. Do we have other irrational numbers? Of course, radical 2. E. Okay, we're gonna study E quite a lot. Okay, so E is a number. Okay, so let me write down what is E. We all know pi, right? E approximately is 2.7183, and there are many, many digits afterwards. There are many, many digits afterwards. They're not repeating and they're not terminating either. Okay, and of course, for your convenience, I'm going to put pi here. This software gives us a limited number of digits, right? From my memory, I think it's 3.14. Keep going. This is how many digits I can remember, but there are as many digits as possible if you wish to find out, right? So it's neither repeating nor terminating. And there are many more such numbers, radical 3, radical 5, and all of these numbers, they are irrational numbers. Next, come to a very important category is that we combine all of these numbers together, and we call them real numbers. Okay, so real numbers include what? Include the rational numbers, union, okay? Union, put them together, and irrational numbers. So in this semester, most of the time we discuss real numbers, but beyond the real number, do we have other numbers? The answer is yes. The answer is yes. We have a even larger category of numbers, and they're called complex numbers. Complex numbers. Complex numbers is another category, okay? It's the largest category yet. It's the largest category yet. Okay, so what are complex numbers? Complex numbers is defined as a real number plus another real number multiply something we call the I. Okay, I is a very special number, and I is equal to square root of -1. Okay, so any complex number can be written in this form. Has a real number, right? When b is 0, you can see, right? So let's see, when b is 0, right? It's all of real numbers. So all of the real numbers are complex numbers, but not the other way around, right? So A and B are real numbers. Okay, so as we will be dealing with complex numbers a little bit, but primarily we'll be dealing with real numbers. So it's important for us to understand what are real numbers, what are complex numbers, and how each kind of these numbers are defined and their categories. Okay. If you have any questions, then please let me know. And that's the end of this lesson.